You know how your iPhone knows what time it is? How Netflix knows when to charge your subscription? How your bank knows when to pay your bills? All of that depends on computers being able to count time. Sounds simple, right? Your computer just needs to know it's Tuesday, November 27th, 2025. But here's the thing that might shock you. On January 19th, 2038, at exactly 3:14 and 7 seconds in the morning, millions of computers around the world are going to have a complete meltdown. They're going to forget what year it is. Some will think it's 1901. Others will just crash, and a bunch of them control things like power grids, ATMs, and the systems that keep planes in the air. Welcome to the year 2038 problem. And yeah, it's a real thing. You've probably heard of Y2K, right? That whole panic in 1999 when everyone thought computers would freak out when the year changed from 1999 to 2000. People were stockpiling water and canned food like it was the apocalypse. Planes were supposedly going to fall out of the sky. Banks would lose everyone's money. Well, Y2K was mostly hype. We fixed most of the problems before midnight hit. But the year 2038 problem, this one's different. This one's actually happening, and we're running out of time to fix it. In the next 15 minutes, you're going to understand exactly why computers are going to lose their minds in 2038, which systems are at risk, and why this matters way more than you think. Because this isn't just about some nerdy computer problem. This is about the invisible foundation that literally everything in your life depends on. So here's what's really happening, and trust me, once you see this, you can't unsee it. Think about every computer system you interact with in a single day. Your alarm clock wakes you up at the right time. Your phone knows when to show you notifications. Your coffee maker starts brewing at 6:45 a.m. because you programmed it. You check your bank account and see transactions from today, yesterday, last week. You book a flight for next month. You set a reminder for your mom's birthday in April. All of that requires computers to understand time. Not just what time it is right now, but also what came before and what comes after. Past, present, and future. Now here's what nobody tells you. Computers don't actually understand time the way you do. They don't know what Tuesday means. They don't know what November is. They definitely don't know what 2025 represents. Instead, computers do something brilliantly simple but ultimately problematic. They count. That's it. Just counting. Like a stopwatch that's been running for decades. Picture this. Back on January 1st, 1970, at midnight, someone hit start on a giant stopwatch. Not a real stopwatch, obviously. A digital one that exists inside millions of computers. And that stopwatch has been counting seconds ever since. Every single second that passes, the number goes up by 1. So right now, as you're watching this, that number is somewhere around 1.7 billion seconds. That's how many seconds have passed since January 1st, 1970. Your computer takes that big number and converts it into something you can actually read. November 27th, 2025. This system is called Unix time, and it runs pretty much everything. Your laptop uses it, your phone uses it, servers at Google, Amazon, Netflix, all using it, ATMs, traffic lights, hospital equipment, factory robots, even the systems that manage nuclear power plants, all counting seconds since January 1st, 1970. Why 1970? Honestly, kind of arbitrary. That's when the Unix operating system was being developed, and the engineers needed to pick a starting point. They called it the Unix epoch. Like how historians talk about different epochs in history. This was the beginning of computer time. And here's where things get interesting. Or terrifying, depending on how you look at it. Remember that stopwatch counting seconds? Well, here's the problem. The stopwatch can only count so high before it runs out of space. Think of it like this. Imagine you've got one of those old mechanical odometers in a car. You know, the kind with actual numbers that flip over. Let's say it's got 6 digits. It can show 000000 up to 999999. That's 999,999 miles. But what happens when you hit 999? 199,999 miles, and then drive one more mile, the odometer rolls over. It goes back to 0000000. It can't show 1 million because there's no room for that seventh digit. Your computer's time counter has the exact same problem, except instead of 6 digits, it's got 32 binary digits, 32 ones and zeros that can count up to about 2.1 billion. And that 2.1 billion seconds, that takes you to January 19th, 2038 at 3:14 and 7 seconds a.m. 1 second later, the counter rolls over, just like that odometer, except instead of going to 0, it goes into the negatives, into the past. And suddenly your computer thinks it's December 13th, 1901, or it just crashes because it doesn't know what to do with a date from 1901. The software wasn't designed for that. It's like trying to play a DVD from 2025 inches, a VCR from 1985. It just doesn't compute. Now you might be thinking, okay, that's weird, but surely someone's fixed this by now, right? I mean, we've got iPhones that can recognize your face and cars that drive themselves. How hard can it be to make computers count higher? And you'd be right to think that. The fix is actually pretty simple. Instead of using 32 binary digits to count time, you use 64. That gives you way more room, like way more. With 64 bits, you can count up to 9 quintillion seconds. That takes you out to the year 292 billion. Yeah, billion with a B. The sun will have burned out long before we hit that limit. So problem solved, right? Just upgrade everything to 64-bit time and we're good? Here's what makes this even more surprising. That upgrade has been available for years. Most modern systems already use it. Your iPhone uses 64-bit time. Your laptop, if it's from the last decade, probably 64-bit. The servers running Netflix and Instagram, all 64-bit. But here's the thing. There are millions, maybe billions of devices out there that still use 32-bit time, and they're not going to magically upgrade themselves. We're talking about embedded systems. That's tech speak for computers that are built into other things. The computer in your car that manages the engine, the computer in your thermostat, the computer in medical devices at hospitals, industrial equipment at factories, traffic control systems, power grid management, banking infrastructure. A lot of this stuff was installed 20, 30 years ago. It's been running fine this whole time. Nobody thinks about it. You don't upgrade the computer system managing a power substation the same way you upgrade your iPhone every couple years. And here's the sneaky part. A lot of newer devices still use 32-bit time even though 64-bit exists. Why? Because they're built on older code. Some programmer back in 2015 copied code from 2005 that was based on code from 1995, and that original code from 1995 used 32-bit time because that was the standard back then. It's like building a brand new house in 2025, but using the electrical wiring design from 1985 because that's what the blueprint said. Sure, it works fine now, but you're baking in a problem for later. This connects to something even deeper. We build our entire world on invisible foundations. The code running in your bank's servers was probably written before you were born. The systems managing air traffic control, some of that code is older than the internet itself, and we just assume it all works until it doesn't. Let me tell you about what actually happens when the year 2038 problem hits, because it's not some abstract technical issue. It has real consequences. There's this pattern I've noticed. I call it the calendar cascade. Here's how it works. When a computer can't figure out what time it is, it doesn't just affect the clock on your screen. It breaks everything that depends on time, which is basically everything. Think about a digital certificate. That's the thing that proves a website is actually who they say they are. When you visit your bank's website, your browser checks the certificate to make sure you're really talking to your bank and not some scammer. But those certificates have expiration dates. They're only valid for a certain time period. So if a computer suddenly thinks it's 1901, every single digital certificate looks expired, which means your browser refuses to connect to any website. Your apps can't talk to their servers, nothing works. Or think about databases. You know how your phone tracks all your photos and organizes them by date? That's a database. It stores each photo along with a timestamp showing when you took it. But if the system thinks it's 1901, where does it put a photo you took yesterday? Before all the other photos? After? The database doesn't know, so it might just corrupt the whole thing. Poof, all your photos gone. And this matters because these systems control critical infrastructure. We're not just talking about your phone acting weird. We're talking about systems that keep water running, electricity flowing, planes in the air. Imagine you're at the airport on January 19th, 2038. You're about to board a flight. The plane's computer systems are fine, those are newer, they use 64-bit time. But the airport's scheduling system, that's older. It thinks it's 1901. So suddenly the system shows your flight as departed 137 years ago. Your ticket looks invalid, the boarding pass scanners don't work because they can't verify the timestamp, the baggage handling system stops because it can't track when bags entered the system. You might think, okay, they'll just restart everything and fix it. But here's the problem. When you restart a system that relies on time, it checks the current time as part of starting up. If it thinks the current time is impossible, it might refuse to start at all. This isn't your fault. You didn't design these systems. But now that you understand the calendar cascade, you can start to see it everywhere. Every system that relies on time, every system is one wrong timestamp away from complete failure. Now here's where it gets particularly sneaky. There's another pattern that makes this worse. I call it the dependency web. Systems don't exist in isolation. Your bank's computer doesn't just sit there by itself. It talks to other computers. It sends data to the Federal Reserve systems. It receives information from credit card companies. It syncs with other banks. It connects to fraud detection systems, backup systems, audit systems. And all of those systems need to agree on what time it is. Because if one system thinks it's 2038 and another thinks it's 1901, they can't communicate. The data doesn't make sense. Transactions fail. Security checks break. It's like if you showed up to meet your friend at Starbucks, but your phone showed 3 p.m. and their phone showed 3 a.m. from 137 years ago. You're both at the same physical location, but you're in completely different timelines. You can't coordinate, the meeting doesn't happen. This happens all the time in smaller ways. You've probably experienced it. You're trying to connect to Wi-Fi at a coffee shop and your laptop refuses to connect. Sometimes it's because your computer's clock is wrong, off by just a few minutes, and the security system rejects you because the timestamps don't match. Now imagine that happening across thousands of interconnected systems simultaneously. Bank A can't talk to Bank B. Hospital systems can't access patient records because the timestamp looks corrupted. Emergency services dispatch systems stop working because they can't log call times. What makes this even more surprising is that you can't just fix one system. You have to fix all of them, or at least enough of them that the dependency web doesn't collapse. And here's the sneakiest part. Some systems you can't fix. They're too old. They're running on hardware that can't be upgraded. The manufacturer went out of business 20 years ago. The original programmers retired. Nobody really knows how the system works anymore. They just know it does work. So they leave it alone until it stops working, which it will. On January 19th, 2038 at 3:14 and 7 seconds a.m. But wait, there's another layer to this. Something most people don't realize. It's what I call the embedded invisibility problem. Remember how I mentioned embedded systems? The computer's built into other things? Here's the wild part. Most people don't even know those computers exist. You probably know your phone has a computer. Obviously. You know your laptop has one? Your car? Yeah. You've probably heard it's got like 50 computers managing everything from the engine to the seat warmers. But did you know your smoke detector might have a computer? Your thermostat? Your doorbell, the vending machine at work, the parking meter, the ATM, traffic lights, elevator control systems, security cameras, the point of sale system at Target, all of these have computers. Little ones running simple programs, but computers nonetheless. And a lot of them keep track of time for logging events, scheduling tasks, recording when things happen, and you can't just update them like you update your iPhone. There's no little notification that pops up saying, update available for your smoke detector. Most of these devices were never designed to be updated at all. You install them, they run for 10 or 20 years, and then you replace them. Except a lot of them were installed in 2015, or 2020, or 2023. They're supposed to last until 2035, 2040, 2045, way past the year 2038. Problem: this matters because when something fails, you might not even realize why. Your office building's HVAC system stops working on January 19th, 2038. The maintenance company comes out, can't figure out what's wrong, the system just won't respond. They might not even think to check if it's a calendar issue. Or your medical device at the hospital starts showing error messages. The nurses think it's broken. They switch to manual procedures. But it's not broken, it's just confused about what year it is. And that's causing a cascade of logic errors in the software. The people who fall into this trap aren't stupid. They're doing exactly what they've been trained to do. Check the hardware, run diagnostics, look for physical problems. Because for decades, that's what worked. Time was this invisible thing that just worked in the background until it doesn't. Your brain does this because humans are really good at spotting concrete, physical problems. We can see when something's broken, but we're not wired to think about invisible systems like timekeeping. Back when we were hunting and gathering, nobody needed to track time in seconds since some arbitrary starting point. You knew it was morning because the sun came up. You knew it was winter because it was cold. But in today's world, everything depends on precise time synchronization. And our instincts don't prepare us for that kind of failure. Now, let me show you how this plays out in real life. Let me tell you about two different organizations preparing for this. There's this company I'll call Tech Corp. Mid-sized software company, been around since the late 90s. They've got systems running payroll, customer databases, product ordering, everything you'd expect. Some of their core systems were built in the early 2000s. Rock solid. Never had a major outage. Their IT director, let's call him Robert, he heard about the year 2038 problem at a conference in 2022. He brings it up at the next planning meeting. Says they need to audit all their systems, figure out what's running 32-bit time, make a plan to upgrade. The CFO looks at the budget, asks how much it'll cost. Robert says probably $500,000 and 6 months of work, just to audit everything and upgrade the critical systems. Maybe more if they find issues. The CFO says, that's a lot of money to fix a problem that won't happen for 16 years. Robert tries to explain the risks, but here's what Robert doesn't realize. To the CFO, this sounds exactly like Y2K all over again. Everyone panicked about Y2K, companies spent millions preparing for it, and then nothing happened. Sure, nothing happened because we fixed it, but from the CFO's perspective, it was overblown. So they put it in the future concerns list. We'll deal with it later. Maybe in 2030, definitely before 2038. For now, there are more immediate priorities. A new product launch, a competitor entering the market, customer complaints about the mobile app. Fast forward to 2037, the company's bigger now, different CFO. Robert retired years ago. His replacement, Beth, inherits his documentation. She reads the notes about the year 2038 problem, realizes they never did anything about it. She escalates it. Now it's urgent. They've got 1 year to fix systems that have been running for 2 decades. Some of the code is so old that nobody currently working there understands how it works. The original developers are long gone. They hire consultants, rush the work, miss things. On January 19th, 2038, their payroll system crashes. Employee paychecks don't process. Their customer database corrupts because timestamps overflow. The ordering system stops accepting orders because it thinks the date is invalid. The company survives, but it's chaos. Weeks of emergency fixes, angry employees, lost customers, millions in lost revenue and emergency consulting fees. Notice how this happened? They meant well. They identified the problem, but they fell into the trap of thinking they had plenty of time, and then time ran out. Now compare that to another company. Let's call them DataSafe. Similar size, similar age. Their CTO, Marcus, also learned about the year 2038 problem around 2022. Marcus does something different. He doesn't just raise it as a concern. He frames it differently. He tells the executive team, we've got systems running 32-bit time. Those systems have an expiration date, January 19th, 2038. That's not a maybe, that's a certainty. The only question is whether we replace them on our schedule or in a panic. He proposes a plan. Every time they're already planning to update or replace a system for other reasons, they make sure the new version uses 64-bit time. They're upgrading their payroll system in 2024. Make sure the new one uses 64-bit. Replacing some servers in 2025, get ones that use 64-bit time. It costs basically nothing extra because they're already doing the work. They're just being smart about the specifications. Plus, Marcus creates a registry. Every system in the company documented with whether it uses 32-bit or 64-bit time. And every year, during budget planning, they identify the oldest, most critical 32-bit systems and prioritize replacing them. By 2030, they've replaced about 60% of their vulnerable systems. Not in a panic, just gradually. As part of normal business operations, by 2035, they're at 90%. The last few systems are isolated, they don't affect anything critical, so if they fail in 2038, it's annoying but not catastrophic. January 19th, 2038 comes. DataSafe has one minor hiccup. An old logging system that nobody realized was still running stops working. They notice it, shrug, and shut it down. Everything else runs fine. Notice how Marcus understood something that Robert didn't? This wasn't a future problem, it was a current problem with a future deadline. The decisions needed to happen now, even if the consequences were years away. Here's what most people don't realize. The year 2038 problem isn't a technical problem, it's a priority problem. The technical fix is easy. You upgrade to 64-bit time, done. The hard part is convincing people to fix something that won't break for years. It's like climate change in that way. We know what needs to happen, we know how to do it, but there's always something more urgent, something that feels more immediate, until suddenly it's not future anymore. It's now. And now you're in crisis mode. The people who succeed don't have some special technical advantage. They understand that invisible systems need attention even when they're working fine. Especially when they're working fine. Because that's when you have time to fix things carefully. And once you see it this way, everything changes. You start asking different questions. Not, will this break, but when will this break, and am I prepared? Not, can we wait to fix this? But what's the cost of fixing it now versus fixing it in a panic later? These patterns aren't personal failures. They're predictable traps that anyone falls into. The assumption that we have time. The belief that invisible problems can wait. The tendency to prioritize the urgent over the important. But now that you understand how the calendar cascade works, how the dependency web connects everything, and how embedded invisibility hides problems until they explode, you can see this pattern everywhere. Not just in computer systems, in infrastructure, in organizations, in your own life. So here's what we've uncovered. Computers count time in seconds since January 1st, 1970. Many of them can only count to about 2.1 billion seconds. That limit hits on January 19th, 2038. When it does, systems will crash, reset to 1,901, or just stop working. And because everything connects to everything else, one system failing can cascade into widespread problems. Plus, the systems most at risk are embedded and invisible. We don't think about them until they stop working. And by then, it's too late to fix them carefully. You're in emergency mode. This isn't just about computers. It's about how we handle predictable problems with distant deadlines. It's about the gap between knowing something will happen and actually preparing for it. The question isn't whether the year 2038 problem will cause disruptions. It will. The question is whether you'll recognize the pattern when you see it, because now you know about the calendar cascade. About the dependency web, about embedded invisibility, you can't unknow it. So next time you hear about some system that's working fine but hasn't been updated in years, ask yourself, is this working fine or is this a time bomb counting down? Because once you see how these invisible foundations can crumble, everything looks different. The systems running your life are counting down. Most of them will be fine, but some won't. And the difference between chaos and smooth sailing isn't luck. It's whether someone asks the right questions early enough. January 19th, 2038, 3:14 and 7 seconds a.m. 13 years from now, the clock is ticking.